Dear friends, welcome back. The machine I'm going to do together with you would be Foxhole in this video. The link will be added into the video below so that you can download and play the machine if you want. Before we go ahead, if you don't mind, please subscribe to my channel and leave a like below. You're greatly appreciated. So enough talk, let's just get started. We can switch into the Kali Linux VM. First of all, we need to discover the IP address of target. The utility I'd like to use, as always, would be net discover. As you can see over here, I use the option of -I to specify the interface to send and receive the packets to discover the machines on the network. And use the option of R-R to narrow down the network range. So this would be faster. Okay, so now we can press enter. As you can see over here, the IP address of the target could be recognized as 164. So then what we are going to do next, we need to do enumeration for the port and the service. To save time, I've already done that earlier. So now we just get out the result of map scanning. As you can see over here, I use the option like scene scan, the version scan, the default script scan, followed by the -P- to do the full range port scan. The last option for all is ON to output the result into this file. Although the IP address has been changed from the first time when I did the machine. So from the map scanning, we can tell that the target has two open port numbers. The first one, 22, which is running SSH service or secure shell service, and its version number information. As we know, this version doesn't have any vulnerability. The next one is 80, which is running HTTP service, and also the version information, which is Apache 2. So what we are going to do next is to do the enumeration with the HTTP service, both manually and automatically. So let's fire up our browser of Firefox and put the IP address of the target into the address bar. Press enter, and we can go to the page back. This page is full of very beautiful pictures, and of course, this always certain we need to check its source code, because in some cases we can find something important from the source code, but this is not the case. And next we can check its robots file. Yeah, as you can see, we got this one, secret, and we can access this file, secret. And there is a very funny picture, Jebedit, nothing useful, some sort of rabbit hole. However, I think we need to check, or we have to check its source code. As you can see here, there's some, maybe, this HTML code is not written properly. There'll be some error, but this doesn't matter for us. So there is a hint somewhere, though. Keep looking. Of course, we will keep looking. No problem. So next, we can use some sort of utilities or tools to do the automatic enumeration. For example, the first two I always use is Nikto. And we can, as you can see over here, very important information about the web application can be retrieved, and some like the header information, the version information, also some, the common directories. Although it's built-in dictionary, it's not so much big. Okay, and I think we need to take a look at the such discovered directories. Like this case should be images, and there's so many pictures. And but before we go into each of them, to analyze, I'd like to take a look at other files. For example, like admin and also readme. Admin, maybe I need to look at this first of all. Try harder. There is no admin panel here. And we can check its source code and we can scroll down. So maybe take a nice deep look at that one purple fox picture. So I think this should be hint left by the author. We need to look at the purple fox picture very carefully, which will possibly contain some important information. And if we go back to the images, so we're images directory. And here, the two files from the name, we can know that we should open up, we should download these two pictures. And we can download and to the working directory on the Kali Linux. And the second one, and we can download as well, no problem. So next, I think is very straightforward, so that we need to analyze these two pictures. For example, we can use Exif2 and Foxy, and to see whether there's some hidden or important information which lives in the metadata of pictures. But if you scroll up or scroll down, nothing like that we can get. So next we need to use, for example, like stack hide or stack seek to see whether there's some hidden message inside those two pictures. For example, the first one I always use is stack hide, and with option of extract and SF, and followed by the file name. No passphrase, so couldn't extract any data with that passphrase. So next we need to take a look at another one. No passphrase. As you can see, wrote extracted data to this file. Of course, we need to get out this text file, and the content inside this file is encoded, and we can copy and to decode. And of course, you can use subchef, but I think it would be more convenient if we use the command line. Not this one, sorry, we can echo, and we can paste the encoded data and tunnel to base 64 with option of the -D to decode. As you can see, we got the username, Fox, and also the password. So we can copy the password and the username onto our notebook. So it should be the creds, and the username should be Fox, and this should be the password. So then I think we can check whether we can use this credential to log into the target via SSH. And so we can SSH Fox, and we can put the IP address of the target here, and we can provide the password for this user. It does work. And next we need to do some local immersion. Of course, this mission is very straightforward. We just follow the steps or the instruction or the direction left by the author intentionally. For example, here we can immediately notice this binary, and this binary give me root. The name has already told us we need to utilize this binary to elevate our privilege. And also another important point is that this binary has SUID bit, even we do not need to use the limpia shell script or some find command to discover. All right, so I think next we need to download this file or binary or payload onto the Kali Linux, and then we can use some tools to analyze. Okay, so how to do? We can use different ways to download, but I always prefer I think from my point of view, is easiest way is to set up the web server by Python Python 3. So we need to check whether Python 3 is available or not. It's there, and then we can use the http.server module to set up the web server on the target. Next, we can copy the file name, and we can go to another tab. We can use wget to download. Put the IP address of the target and the port number, and we can paste the file name. No problem. I think now we can close up the. So where? Anyway, maybe I need to log into the target again. We can. I'm not sure what I have already done, what I did, but this doesn't matter. So next, I think we need to use some tools. For example, we can use the. Maybe we need to make it executable first. Give me, and then we can use the file command to display the type of file. As you can see here, it's 32-bit LSB or Linux executable. And next, we can use strings to display the readable characters of this binary. And we can scroll up. As you can see here, do you want the root password? You didn't convince me. Also here, we can notice the bin bash is in this executable, okay? Very important information. We need to keep this into our mind as we move forward, all right? So next, I think we can run this binary. And do you want the root password? For example, maybe we can put anything, for example, like yes. So you didn't convince me. Maybe you should write me very long reason. So I think this is another very clear hint left by the author, very long. So maybe this, I think probably this binary is vulnerable to buffer overflow. So how to make such testing? Because we have already downloaded this binary onto the Kali Linux, then we can launch our GDB to make debugging, and we can run. For example, we can feed some long data, and to create the long data, we can use Python, and we can, for example, Python 2 or Python 3, which doesn't matter. We can use the capital A, and we can put 2000. So 2000 capital A. Press enter. So the payload has been created. We can copy this payload, and then we can paste in here. As you can see here, I think the program or this executable has crashed, and also give us the reason sec_v, and even give us the location or the address. Of course, this one 41 stands for the capital A in hexadecimal. Okay, so we can know, for example, if you want to display, usually this one should be the memory address. You can use the information register to print out the register information here. If you want to retrieve the data of this address, we can use for example, the X, and we can copy this address here. Of course, this is not a valid memory address at all, so give us an error cannot access memory at this address. So far we have didn't know that the target or this executable is vulnerable to buffer overflow vulnerability. However, next we need to know where this program crashes accurately or exactly. So how to? We need to use some utility to generate the pattern. This pattern has a specific, I can call it the pattern. I mean, the payload has some specific pattern. Okay, so let me show you in practice. So how to do? We can use the Metasploit utility. Meta sprite, tools, exploit, pattern, and create. And we can create 2000, the payload, uh, the length of the payload is 2000, and we can press enter. And now we can copy this payload, and we can run or fit to this binary. We can use the R, rerun, and put in here. As you can see here, we got the the program crashed again. And here we got this address. Actually, this address is the address of the EIP. If you can print out the register, as you can see, this is the address of EIP. So it means that we have already know that where the program or the binary crashes. So next we need to know the offset or the location of the EIP. So how to do? We can use another related utility to calculate the share metasploit and tools exploit pattern offset, and the length is 2000, and the address EIP address should be sorry about that, not this one, and 2000. And we can copy this address. This address is where the program crashes. Okay, so we can copy this one, and we can paste in here. As you can see here, we got the offset value, which is 516. We can copy and note it down to a notebook. So now at this point, we have already know that the exact location where the program crashes, or is where the EIP, where the EIP is, okay, in the stack. So next I think we can confirm by feeding more payloads. For example, we can use the Python 2, and we can print the length should be the offset, and we can then followed by the capital B, and the length is 4 bytes, and we can add capital C. Okay, press enter, and we can copy this payload and rerun this program again. As you can see here, the EIP this time is overwritten by the 4242. 42 means capital B in hexadecimal, okay? And of course, this is not a valid memory address. So next, I think we need to, so far we have already know the offset, and also we know, the target is vulnerable to buffer overflow vulnerability. Next, we need to find the bad characters, because we need to run the shell code. However, do you remember? Just now we use strings command to know that this binary will run the bin bash. So I think we do not need to, run we do not need to put or insert the shell code to get the privileged shell. I think we can utilize the inbuilt the bin bash command. However, we need to know the location or the memory of address of the bin bash. So how to know? I think we can, for example, we can use the I function to display the all functions, and we can scroll up, and I think we can find some sensitive function of this executable. The executable we can the give me loot, please. Yeah, this executable, and we can scroll up. Almost at the very beginning of the output, as you can see over here. And this should be the main method or main function, and also the overflow. But this one secret caught my attention most. So maybe we need to disassemble this function and to see whether we can find or utilize this function. And we can use disassemble. And function should be secret. As you can see here, and this should be the the assemble language or the command or statement. But I think this one system at POT, it means that this function will execute system command. So maybe we'll execute the the bin bash command or binary. Okay, so next we need to get to know the address of the memory address of the secret function, because we want to put this address to EIP. EIP is the extended instruction pointer, which store the memory address of the next instruction. So if we put the address of the secret function, and then I think the secret function can be executed, because the EIP has been overwritten by this memory address. I hope I have already made it clear. So next, of course, just now we can get the memory address of the secret function. We can scroll up again. Sorry about that. I think this address we can copy, and we can put it here. So of course, this address, because the system uses the little endian format, we need to reverse this address, like this one, xad, x62, x55, x56. I need to double check ad 62, 55, 56. Next, we need to create the payload. Of course, we can also use the Python. And how to do, we can use Python. Maybe I can use Python 3 or Python 2, doesn't matter. Maybe Python 3, because I think on the target, no Python 2, just Python 3 is available. Okay, so now we can use the Python 3 print. Should be 516, and then followed by the address of EIP, and in this address should be overwritten by the address of the secret function. Okay, so we can copy, and and also I stated earlier, because in this case we do not need to put the shell code to make buffer overflow attack. The reason is that the give loot to me, this binary has bin bash command. We just want to utilize the built-in bash command to elevate the privilege. Okay, and we can copy and put in here. Oh, we need to redirect or save to the file, and then we can go back, and then this time we want to input from the file POC1, and we can run it. However, as you can see here, stop reason. I think here I think we can use to display the EIP, because just now, do you remember, the address should be 56, not 55, right? And also the C2 is inserted. So very weird. This is very different from other similar machines. I mean the buffer overflow attack machines. So it means that we need to make some change. You know, we need to, for example, we need to move back 1 byte to the to move back the, I mean, in offset. Let me show you. We can use reduce the offset 1, and we can press enter, and then we can run it again. You see, as you can see here, this time we got a different output and no such error, sec v error, and instead we got this one. The process is executing new program, the bash, of course, which sounds very great, wonderful, because this is just what we want, right? So I think this would be a very clear what we can do next. We need to, now we can go to the target and run this program, input or fit this payload, the same payload. Okay, so we can copy this command, and we can paste in here, and then we can, for example, we can cut out this one to input, and we can tunnel. However, we got the segmentation fault. So this is not what we expected, right? The reason, of course, to be honest, this is the first time I met this situation. The reason is that when we cut out this one, and the standard in or STD in would be closed. Actually, at this time, the payload has been fit into this binary, but although the root shell has been got, however, the shell has been closed in very short time. This is the reason. So how to sort it out, this issue? We need to trick the system to let the STD in or standard in to be running, to be open, and then we can get the privileged shell. Okay, let me show you. We can use the cat and the POC, and we use the semicolon and the cat. However, we do not cat anything. So this STD in or standard in would be open all the time. And now we can tunnel to our binary. And because I need to repeat again, this binary or this payload has SUID bit. If we can overflow this, it's a buffer of this binary, and then because this binary has bin bash command, the embedded, and then we can get to run the bin bash, and then we'll temporarily get the ownership of the this router. Okay, so I can press enter, and we can run the ID. As you can see, we are successful, and now we can navigate to root directory, and then we can cut out the flag. So I think this machine is very interesting. It deserves your own practice, and so you can learn and practice a very different techniques, especially buffer overflow attack techniques. So that's pretty much it. I'd like to see you in the next one. Bye. Have a nice day, please.